Hello and welcome back to Science of Medicine. I want to continue our discussion of the endocrine system by focusing on the thyroid and parathyroid glands in this lecture. The thyroid and parathyroid glands are located in your anterior neck. If you actually feel where your cricoid cartilage is, which is that little cartilaginous part that bows out or bows out from your throat, and you go down about 2 finger breadths and go just to the sides, and you can feel your thyroid gland as you swallow. The thyroid gland is a little unique in that it contains the parathyroid glands also. And although they are physically in the same location, they produce different hormones that have different effects. And I'll talk about that in a minute. So let's get started. So talking about the thyroid gland, I have 2 hormones. Thyroxine, which is also called thyroid hormone, is what is produced by the thyroid glands as a result of stimulation from the anterior pituitary thyroid stimulating hormone, and that in turn was stimulated by thyrotropin releasing hormone, which came from the hypothalamus. This works via a negative feedback system. So if I have too little thyroxine, I can feed back to get more TRH and TSH. If I have too much thyroxine, I can feed back and get less TRH and TSH. Now, independent of this, the thyroid gland also produces calcitonin. Calcitonin is a minor player, but still a player in calcium regulation. But it has nothing to do with thyroxine, other than it happens to be produced in the same gland. Parathyroid hormone is another hormone, but it is produced in a set of glands which are embedded within the thyroid glands called the parathyroid glands. And parathyroid hormone is essential in regulating our calcium. So just keeping the players straight, again, the thyroid gland produces thyroxine, which we'll talk about in terms of its metabolic effects, and calcitonin having a small role in calcium regulation. And then embedded within the thyroid gland are normally 4 parathyroid glands, and they secrete PTH, which will regulate calcium, and we'll see that in a few minutes. So let's focus on thyroxine. So as I mentioned to you, the TRH, TSH, thyroxine axis is under negative feedback control. Now, I'll talk about the synthesis of thyroxine in the thyroid gland in just a moment, but it is an iodinated compound, derivative of tyrosine. And normally, if it has 4 iodines on it, we call it T4, and if it has 3, then we call it T3. So you'll see those terms that are used also. The free or unbound form of T4 is what is physiologically measured and used because most of the T4 is actually bound to a transport carrier protein. Now, inside the cell that are targeted by thyroxine, T4 is converted to T3, and then it is actually acting as a transcription activator. As I mentioned, the T4 is bound to thyroglobulin, which is just basically a transport protein that will go through the blood. And so it is the free T4 that is what is able to actually go inside cells. Now, what does it do? For the most part, it increases metabolic activity. That means that it increases basal rates of metabolic activities, and that's why sometimes people who will lose weight can lose weight from an overactive thyroid gland. It also has increasing rates on cardiac output through both heart rate and stroke volume and GI motility as well as respirations. So many, many types of effects on a cellular level. As I mentioned, the thyroxine or T4 is synthesized in the thyroid gland. The thyroid gland is made up of cells that are called follicular cells, and you will actually concentrate iodine from the bloodstream in these to be able to add iodines to this tyrosine derivative. And you'll eventually wind up with T4 or thyroxine, which can then be transported out via blood and the thyroglobulin carrier protein. Many years ago, and in some areas still today worldwide, where there is an iodine deficiency, you will see hypertrophy or enlargement in the thyroid gland as it tries to synthesize enough T4. Such a goiter is something that you used to see more about 100 years ago or so, even in this country. And then we started to iodinate by adding some sodium iodide, a small amount, to the sodium chloride that is used as a seasoning agent. So what kinds of diseases can afflict thyroid deficiencies or excesses? Well, as I mentioned, you can have too much or too little. If I have too much, I call it hyperthyroidism, a thyroid state that is producing an excess amount of thyroxine. However, I have 3 different types of hyperthyroidism that I could have. The first is I have a high level of thyroxine that is produced by the gland itself, and that's called primary. The second, called secondary, is where I would have a high level of TSH, which is then stimulating the production of high levels of thyroxine, and that would be an anterior pituitary problem, and that's called secondary. And then tertiary, exceptionally rare, tertiary is where I would have a hypothalamic problem, where I would have an elevation in the level of TRH, which would then stimulate TSH, which would then stimulate increased production of thyroxine. So I have to distinguish between those 3 cases, and this is the first type of disease process in endocrine that we've talked about that has this, although there are others which we'll talk about. By definition, the endocrinologist will consider if the organ producing the hormone is the problem, they call that primary. If it's the previous hormone producing organ, then it's secondary, and if it's even beyond that, then it's tertiary. Hypothyroidism, or a deficiency of thyroxine, can also be primary, secondary, or tertiary, as I had mentioned for the excess case. So let's take a look at this. If I look at the case of hyperthyroidism, under the case of a normal thyroid or euthyroid, I would have a normal level of TRH, which would then generate a normal level of TSH, which would generate a normal level of thyroxine. And this is where most people are. But if I have too much T4, then I will have an increase in thyroxine, but because of the negative feedback system, TSH and TRH will be decreased. On the other hand, for secondary hyperthyroidism, it is the problem with the anterior pituitary cells producing too much TSH, which then means that the thyroxine will be increased, and then negatively feeding back the TRH will be decreased. And this is in contrast to tertiary, where all 3 of them are increased because it is the TRH driving the TSH, which then drives the thyroxine. Similarly, for an underactive thyroid, for hypothyroidism, I now have a decreased level of thyroxine being produced in primary, but increased levels of TRH and TSH because, again, the negative feedback system, it's trying to compensate for that decreased production of thyroxine. Secondary shows a decrease in both the TSH and the thyroxine, and tertiary where it's decreased in all 3. So it's important that you understand this. We'll see with cortisol diseases that this can also happen as a primary, secondary, or tertiary. Now I'm going to switch gears and go to the parathyroid glands. The parathyroid glands produce PTH, and parathyroid hormone, or PTH, is intricately involved in calcium regulation. Now, calcium concentration is highly regulated in the body. You know from previous discussions that intracellularly that is involved in a lot of processes, for example, in skeletal muscle with facilitating contraction of that muscle. And it is also highly regulated in the extracellular space, especially in the blood. And so in this case, the stimulus for parathyroid hormone is going to be that calcium concentration. Now, it is the primary mover for calcium concentration, the primary manner by which I can adjust calcium concentration. Calcitonin, which is a hormone that is produced by the thyroid gland, also will influence that under certain conditions, but it is not the major player. So let's talk about PTH. So if I have too little calcium in my blood, then I need to stimulate the freeing up and saving of calcium to raise that back up to its homeostatic level. And parathyroid hormone does this exquisitely well. So much of the calcium in the body is stored in hydroxyapatite in our bones, which is a calcium phosphate hydroxide molecule that will actually store a lot of calcium. If I have too little calcium in my blood, PTH will be secreted, and that will cause an increase in osteoclast activity. Now, osteoclasts, remember, will actually cause bone to actually be desorbed. In other words, that you will actually dissolve that hydroxyapatite, and that will free up calcium along with phosphate. Another effect that PTH has is that you will reabsorb calcium in the kidney in the proximal convoluted tubule. You'll also get an increase in calcium absorption in the intestines. That's mediated through a vitamin D process. And then PTH is sometimes referred to as phosphate trashing hormone because PTH effect will also decrease phosphate reabsorption in the kidney. The reason for this goes back to sort of the equilibrium for solubility product constant. So calcium, phosphate, and hydroxide, this hydroxyapatite, can dissolve into calcium and phosphates and hydroxides. So if I want to increase the amount of calcium, I can also decrease the amount of phosphate or hydroxide. But since it is to the 6th power for the phosphate, you look at the expression for the solubility product constant, the phosphate is a much more sensitive one, so I can actually trash or get rid of or release phosphate from my kidneys, and that's why it's done. So that is a very exquisite mechanism by which I am actually controlling calcium in my blood. In a slightly different way, if it turns out that I have too high a calcium concentration, then I suppress parathyroid hormone and I stimulate calcitonin. And calcitonin will decrease, and the decrease in PTH will decrease osteoclastic activity and increase osteoblastic activity to make more of the hydroxyapatite. And it will also allow for my kidney to flush out calcium and not reabsorb that as much in the kidney and not reabsorb it in the intestines. So what kinds of problems can I have? As always, I can have too much or too little. In this case, if I have hypercalcemia, an excess of calcium, that can cause a variety of things. One of the ways that medical students remember this is called stones, bones, groans, and psychiatric overtones, because I'll get stones in the kidneys that will form nephrolithiasis if they're calcium-based. So calcium oxalate, calcium phosphate stones can form. And if I have an increase in concentration of the calcium, that will also lead to an increase in the formation of those stones. I can also have from this increase increase in calcium concentration, I can have bone pain. If you remember, for the hypercalcemia, that I'm going to start forming more bone with osteoblasts. And then I can also have problems with gut motility and with abdominal pain, as well as with some mental issues related to excess calcium. If I have too little calcium, hypocalcemia, too little calcium in the blood, that can be deadly. I can have cardiac arrhythmias, muscle contraction problems, carpal spasms and things like that. So I hope I've given you an overview of the thyroid and parathyroid glands. As you work through those, think about that they're very different. They just happen to be located in the same area of your body, but they actually do many different things. We'll see this also for the adrenal glands. There are many different things that the adrenal glands will produce in the way of hormones, and they just happen to be situated in close proximity. As always, if you wish, please go ahead and subscribe to the channel, and you'll know when videos come out. You can like or comment if you have any questions, and otherwise I will see you soon.